All right, everybody. On Google Classroom, earlier today, they posted a link. So let's see where that is. Go to your class. Okay, and that link, one of the links there, the one that's important today, is the Physics Classroom link. So if you open that up, find that link and go to it, we're going to guide you around this. This is essentially going to be our textbook for the year in here. We might use another textbook at times, especially for the first couple of weeks. We're going to work primarily off of this. So once you open this up, open the link up, bookmark it so you can always access this site quickly. Just going to run down through some general things about this. The main part of this is called the Physics Classroom Tutorial. And when you open that up, it's basically all the links that pop down from there are like chapters, essentially, of a book. And we're going to start in a few days, not quite yet, but in a few days with the first segment or chapter-like part of this called 1D Kinematics. And just to give you a quick background of what that means and what we'll be learning about, 1D means one dimension. So we said the other day in class that in physics, we start small and keep building up to different kinds of motion. So the easiest kind of motion you could imagine would be something going on one dimension or like on one axis. Like imagine like a ball rolling across a table or something like that. I mean, it really starts simple, but you'd probably be surprised how such a simple task like that, how much you could look into and figure stuff about it. So when we really get going, past a little bit of metric review we'll get to here soon, that's kind of where we're going to start. And you can notice when I open this up, it breaks down into lessons. These are the lessons there'll be study guides on. And some lessons have parts A through E or bigger or smaller, whatever. The study guides were made by the same people that make this website, so they go along pretty much perfectly with everything. And whenever we do eventually have a quiz here, a test there, the study guides will be what we'll primarily look at for that stuff. But one other big thing we'll use on this site frequently is going to be something called concept builders. And interactives as well, but more importantly, concept builders. Now, there's something on these that just changed over the summer, and earlier today, I just found out the change because I haven't been on it since the end of last year. I've been using this site for probably 15 years at least, and everything, 100% of it, used to be completely free. Now they're kind of charging to use this. We can still use it for free, but it's limited as far as how we used to be able to use it. So no matter what, we're still going to use it. I just still have to find some workarounds to how we turn it in compared to how I used to. But I also have a request in the office to purchase it for us. And I think they're going to, but I'm not 100% sure. So if we get it purchased for us, we'll actually be able to give you all a username and an account to this. And then it will track these that you do. And it'll be real easy. You won't really have to turn them in. I'll be able to just look and see that you did them. And that'll be the nicest thing. So hopefully the district purchases it for us, and I think they're going to. It just might be a little bit until they do. Either way, whether they do or don't, for at least a little bit of time, we'll have to use the free version of it, where the downside of that is when we open some of these assignments up on here, they won't be able to be saved. So if you use a free version, you have to finish them in one setting or leave the tab up, which could be a pain in the butt. Because if you close it and you lose that tab or it shuts off, then you're done. Now, the good news is most of the time in one sitting, you could probably finish everything. They're not like huge. They're mostly small assignments, or I could break them up into smaller. But hopefully we have the paid version soon, and we won't have to worry about that. But to kind of do two things at once today, give you an idea how these concept builders work, because you'll be using them for many topics all year, and to give you at least begin somewhat of a metric system review, I'm going to use that for both of these right now. So I'm going to click on the one down here that says metric conversions. And those of you at your seats that are here, you could click on it if you want and start it. But it's probably more important you just follow the one I do, because when we get to the actual questions, it randomly generates them. So you won't necessarily have the same question we're all looking at on the screen here. So just mostly follow along with me here just to get familiar with them. Okay, so once I select the one I want, it'll take me a screen where then I have to click Launch the Concept Builder. Now, some of these are in the forms of just some questions. Since we're just reviewing some metric system stuff while we do this one, it's just going to be mostly questions, but some of these are like much more interactive than that. Sometimes there's like almost little simulations involved with them, and a lot of diagrams and stuff, like, and puts things into motion rather than just seeing it on paper. So that's another good reason why you use a lot of these. It makes you think instead of just like memorize terms and stuff like that. Alright, so anyways, once it launches, it'll be launched in a smaller window, and we can maximize it to full screen. So here's one of what I just realized in the past few days. One of the things that's different now, there's even a warning on it now that it says you are not using this concept builder as a logged in student. Alright, so if we don't have a login, which none of us do yet, it'll just say guest down here and we can't change it. What we used to be able to do is just type your name in there, and it would not save your work, but at least when you were done, it would give you a certificate with your name on it. We'll just have to stay logged in as a guest and hit start from here until at least hopefully we eventually get the paid version. All right. Most concept builders, not 100% of them, but I think overwhelmingly most of them have 3 levels to them. Apprentice level, master level, wizard level. It's very important that when I assign these, that you read the directions or pay attention to me in class when I assign them if you're here live, which ones I assign, because I won't always 100% of times assign all 3 levels. But some problems I had in the past is students not paying attention or not reading directions and assuming they had to do all 3 levels and then complaining when they got stuck on one. I might only assign you a certain level simply because of how far we got in class or how far we discussed, and you might not have any clue on the other one. So just really pay attention to make sure when I do officially assign these, if I told you to do all 3 or just some of them. Usually, not all the time, but usually the first level will be called the apprentice level. The mid-level is called the master level, and the highest level is the wizard level. There's all on the same topic, but they all, for whatever way, shape, or form, get a little harder. How many questions are in each one really depends on the specific concept builder we're on. These ones happen to have 6 each. That's not always the case. Depending on how many questions there are, that will determine how many points I choose to assign the task, but I'll always let you know in advance. I don't usually make these a really large amount of points. I would say anywhere between 10 to 15 points usually is what they'll end up being. Alright, so I'm going to, for example, click the beginner level of this metric conversion one. And while we're doing this, we're also at the same time going to be reviewing some things about the metric system. Okay, so one big thing that you probably already know, that in science and engineering, anytime you've taken a science course or some of the pre-engineering courses across the hall here, is that most of the time the teachers will make you use the metric system. But on the flip side, we're probably almost comfortable with the English standard system. And we're not doing that to like make your life miserable. We're actually trying to make it better. But there's a reason, a really good reason, for using the metric system for calculations in science and engineering. And do you happen to know what that reason is? There's a special number that the metric system is based on. Do you happen to know it? It's the number 10. All right. Every basic conversion in the metric system is based on the number 10. I'm going to use a meter stick in a minute here to give you examples of that. The English standard system that we're all probably most used to uses really no rhyme or reason to convert stuff. It's just what somebody or a group of people felt like doing and build over time. It's just really a lot of garbage that's just to be good at the English standard system, you have to memorize a lot of different stuff. I'm not saying you don't have to memorize stuff for the metric system, but it's a lot less because it flows on a number and there's a lot of consistency to it. So the biggest reason, some of you might wonder, well, why the heck, if metric system's so better, why is the United States using the standard system? And the main reason behind that is we're stubborn, because we don't want to change. People don't like to change what they're used to, even though that change might be for the better. It was tried in the past, somewhere in the 60s or something, to make a mass movement to get us to go to the metric system, but there was such a pushback that people weren't comfortable with. It was basically scrapped. But we're going to try to give you some reasons right now that the metric system is so much easier for converting. Because it's based on the number 10. Now I'm going to switch my screens real quick here for those of you both here and at home, to a meter stick that I could zoom in on here. Those of you in class could look at the one I'm holding. Those of you that are online could look at the one that's on my screen. So the one on my screen is not a full one, but this is the only one I could zoom in with. So just bear with me with it. All right, so this whole thing from end to end is 1 meter. All right, and if you call it a yardstick, I'll hit you with it because it's not a yardstick. So this is 1 full meter, and remember what I said before. The whole system is based on what number? Number 10. So we're going to imagine chopping this meter stick up into 10 pieces. You'll notice that, especially on this zoomed in one on my screen, that every 10 numbers on it is bigger. You can see that 30 is bigger, that 40 is bigger. If you could see more on this one on the screen, there would be a 50 next, and it would have started from the end, which went 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and the very edge of the roller would be 100. 100 is not showing. But there's a reason why they make those bigger and bolder, because counting by tens is the first breakup of this thing, right, for conversion purposes and measuring purposes. So basically, if I chop the meter stick up at all these bigger numbers, the tens numbers, I would chop it into 10 pieces, because it goes 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So chopping that up into 10 pieces would give me 10 equal pieces. Those pieces are now called decimeters. Deci is a metric prefix. Deci means you broke up the base unit, in this specific case is the meter, by tens. All right? We also see other numbers on this thing, the littler numbers, right? So the smaller numbers between all tens would go to 100 if you could see the very end of the meter stick. There'd be 100 of them. And so that means if we took all the decimeters that we first chopped up by 10 and took one of those, which would be from here to here, and chopped that up by 10, we'd have a lot smaller pieces, right? If we did that to every one of those, where the single numbers are. You can see at home. Now we would have a total of 100 pieces, because if I chopped it up into 10, then I chopped those 10 into 10 more, that would total 100, right? So that means there's 100 centimeters in a meter. Okay, and there's going to be a little flow chart I'm going to show you guys and give you guys to help remember all this. So then we could chop it into even more, at least one more time. After that, it would get too small to chop up. But if you notice when we zoom in especially, all the little tick marks on it. If we took all those 100 centimeters and broke those up into 10 equal pieces, we'd now have 1,000 pieces. And that's how many millimeters there are on this thing. So if you count it up, it would take you a while, and it would probably make your eyes go crazy, so take my word for it. If you counted up all these tiniest markings on here, from the beginning to end, you would count from 1 to 1,000. So for every breakup or segment we do of something like a meter stick, when we're doing metric measurements, we give it a new prefix name. So just to review, breaking up by tens once, we called it decimeters. Breaking it up again by tens, turned it into centimeters. Breaking it up again by tens, we turned it into millimeters. Now, technically, you should, by theory, be able to keep breaking up something forever, but it would just go so small, it wouldn't be reasonable for a measuring device to do that. There are metric prefixes smaller than milli. But in our course, it's rare we'll need smaller than milli. Maybe when we get to waves that way down the road, we'll learn about what a micrometer is. Some of you that had biology before and looked under stuff under a microscope might have remembered like micrometers under a microscope, but that's how small you're getting. Like, with a naked eye, you're not going to be able to see micrometers. So as small as we could go on a meter stick is milli, and that's as small as what we'll usually need. Other physical quantities, which just means properties of stuff that we might use in the metric system. Meters is only used for length and distance, but if we want to know how heavy something was in the metric system, we would want to use the grams. So it's very similar. Now I can't show you a visual with grams since it measures mass like I can with a meter stick, but you could imagine the same thing right now. If we had 1 gram of something, well, first of all, 1 gram is a very small amount of something. If you closed your eyes and I carefully placed a gram of something in your hand, you might not even know it's there because it has very low mass. But gram is the base unit for metric base unit for mass in the metric system. And that just means when I say base unit, it doesn't have a prefix on it. Meter doesn't have a prefix on it. It's a base unit. It's like where we start. And then we can put prefixes on it from there, depending on if we break it up or build it up. We could go in the other direction and make bigger prefixes. As a matter of fact, in mechanical physics, the kind we're going to learn most of this year, most things are at least somewhat heavy we study, so we usually go up to kilograms for that, which is a bigger one. It's actually 3 up, you'll see on the chart here in a second. But usually when we're doing mass, we want it in kilograms. If it's in grams, we convert, and that's what we're going to learn about today. The grams could be broken up into decigrams, centigrams, and milligrams as well. And that's what's nice. In the metric system, I just gave you 2 examples of 2 different units, the meter and a gram, that measure 2 different things. But we can put the same exact prefixes on them. In the English Standard System, that doesn't exist. If you wanted to make bigger or smaller length units, you would have to know random number conversions of just what people felt like doing to turn, and many of you may know these. Many of us probably know how many inches are in a foot, which would be 12. How many feet are in a yard, which would be 3, and so on. Some of us may even know how many feet are in a mile. But the point is, it doesn't go by any consistent number. It's all random numbers of what somebody made up a long time ago. And there's no prefixes involved either. It just goes to a whole new different unit. It's not like it goes from meter to decimeter to centimeter to millimeter. What I just said in the English Standard System was inch to feet to yard to mile. And those are just completely different words, right? So it's not like keeping the same base and just changing prefixes. So this is a more well thought out system that really makes the math that goes along with it much easier. And then if we wanted to measure mass in the English Standard System, we'd have to use a complete other form of knowledge that has nothing to do with how you measure anything with length. So there wouldn't be that consistency of using the same prefixes along the way. All right, so to help us remember and do some actually number converting in a second, I'm going to flash up here a flow chart. And I will be posting this soon on Google Classroom. So those of you in class right now, make sure you copy this down exactly as it is. Even those of you at home, it might help to jot this down. I will post a picture of this on the same post that I put this video on, so you could open it up as well. But for the time being, you might want to just write it down to use in front of you as I flip from this screen to the concept builder, which will apply this. So some of you might remember something exactly like this or close from maybe a middle school math class when you first learned about this, or even a middle school science class where you may have used it in the past. We're just going to probably use it more often than you'd ever did in there. So I have 7 total stairs on this thing, you can see. And the very middle stair is just written base unit. And I spoke of earlier what a base unit was. And there's many base units in the metric system, but three very common ones that we're probably somewhat familiar with are grams, which earlier I said is a measure of mass. Liters measures volume, and meters measures length. So the base unit is kind of like, I guess you could consider almost like the ones place. All right, if we're talking like numbers and math. All right. Now I'm going to give you three prefixes, three that are bigger than the base unit and three that are smaller. The reason why they're on stairs is because remember the number 10 we keep saying. Everything's based on 10. So every step is worth 10, a power of 10, okay? So that'll be helpful in a second when we do a real conversion to remember that. So every power of 10 is given a prefix name. So if we get bigger, 10 to the first power prefix is represented by the prefix known as deca. 10 to the second power, and by the way, 10 to the second power is also the same as 100, right guys? So 10 to the second power, or a multiple of 100, is represented by hecto. 10 to the third power away from the base unit would be 10 times 10 times 10, and that's 1,000 away from the base unit, and that is given the prefix name kilo. If we go the other way, the other direction, we're breaking up smaller. Going down the steps from the base unit is breaking up smaller. So deci, and I used that example for the meter stick earlier, deci would be breaking up or dividing up by the power of 10 to the negative 1. 10 to the negative 1 would be like dividing by 10. All right? When we go up the stairs this way, we multiply by 10. When we go down the stairs, we divide by 10. And that's why the power would be considered like negative. So centa would be 10 to the negative 2. That would be like dividing by 100. And milli is 10 to the negative 3, which would be like dividing by 1,000. Now, because everything is based on tens, every step has to be worth tens. So some of these are really uncommon units. You don't see used actually applied often to very few things, but they have to be there because there can't be a missing step of 10. All right. So deca, hecto, especially, other than some exercises we'll do with converting in the next couple days, you probably will never see applied here many places with those. They're there. We should know they're there. But the ones that's going to matter the most are the base units, kilo, because we all probably are familiar with like kilograms and kilometers and stuff like that, hearing that often. Centa, centimeters, especially is a common unit we use, and milligrams, milliliters, millimeters, that's all a common one we use. So this flow chart's going to help us a lot in a second. We want to understand everything mathematically, but this chart kind of takes the math out of it for us, per se. We should still know the math, but this makes it really easy, so even if you struggle a little bit mathematically, you should still be able to do this easily. All right, so anyways, so now that we reviewed that, we'll flip back and forth to that as needed. I'm going to go back to this concept builder, and while we're doing the concept builder, where did I open it up? Oh, it's way back here. Okay. I'm also going to keep familiarizing you guys with the general way these concept builders work and do the metric stuff at the same time. All right, so this first question on here, and remember this one had 6 questions involved, asks us to convert 0.25 centimeters to whatever amount of meters it goes into. And this gives us a nice visual to do it, and it's nice and neat. I mean, we could all do this on paper too, but this just provides a nice, clear thought process on what we got to do here. So the base unit involved. The base unit is always the first letter. If there's only one letter, that one letter is the base unit. But if there's 2 letters, the C is the prefix, the M is the base unit. So M obviously stands for what? What's base unit? Meter, right? Okay, so this is asking me to convert. The number originally is in centimeters, 0.25 centimeters. We want to convert to what it would be in meters, changing the prefix to the base unit, from centa to the base unit. So here's where that stair chart comes in handy if you're a little rusty with this. Or even if you're not, it just comes in handy just to provide a nice guide here. So where are we starting? The first unit, but the number was given, it was centa, right? So we start on this step. and the base unit is what we're going to. A meter is right here. So how many steps away is the base unit meter from center? 2. And count like this. Don't start counting with the one you're on. Count with every motion. It would be 1, 2 steps away, just like that, right? So center is 2 steps away. So that means we're going to move to do this conversion 2 decimal places. But we got to remember that we can move the decimal places either right or left. But the stair chart helps us with that as well. So if we're 2 steps away, we know that for the conversion we move 2 decimal places. To move right or left, we look at the directions the stairs are going. If you draw this chart right, when you move up the stairs, you go to the left, don't you? If you go down the stairs, you go down to the right. And that tells us exactly what direction to move. So if we started with center and go to the left to get to that 2 steps to get to that base unit of meters, that's basically say that out loud or say that to yourself and you know what to do. Two places, 2 decimal places to the left is what we got to simply move that. So we'll go back to the concept builder here. 2 places to the left. Now if there's no numbers there, what numbers do you think we put there? Zeros. And you can see they do that. All right. So 0.0025 would be what 0.25 centimeters is when converted to meters. And if you really think about it from what we said before on the meter stick, centimeters are a lot smaller than meters. They're the tiniest numbered markings on the meter stick. So 0.25 centimeters would just be a fraction of that, those tiny numbered spaces. And if we tried to convert that into a bigger unit of meters, they would be even a smaller number. Hopefully that kind of makes sense. All right, so the stair chart takes the math thinking kind of out of it. But we don't want to throw out the math thinking, so there's extra questions here. The number one thing is you could accomplish what we just did right there, and we'll get to a couple of more examples in a second. But understanding, not just from the stair chart, but what did we do mathematically? Every time you move the decimal place, you basically move it by a power of 10. All right? So if I move the decimal place 2 times, that means I moved it by a power of 10 to the second. What did we say earlier 10 to the second was? What number? 10 times 10? Oh, okay, 100, right? It could mean a hectare depending on how we're moving, but just in general, 100, okay? So since I moved it twice, I did something by 100 mathematically to further understand this. Whether I moved it left or right determines did I divide by 100 or did I multiply by 100. All right, so that's the first thing this says. On a calculator, if you would do this conversion without a flow chart like we just did, and just did it straight up mathematically on a calculator, to change 0.25 to 0.0025, well, did the number, I don't care about the units for this question, did the number get bigger or smaller? We started with 0.25 and it went to 0.0025. Smaller, the number got smaller. So when we divide in math, we make numbers smaller, right? So if we move the decimal to the left, that was what we're really doing mathematically is dividing. So we'll click on dividing there. There's only 2 choices, multiplying or dividing. All right? Had we moved it to the right, the number would have got bigger, and that to get a number bigger of those 2 options, you would have to multiply. But we went to the left here. And since we moved it 2 places, and each place is a power of 10, we divided by 100. So straight up mathematically, and some people do like thinking about it this way better. The mathy people out there that are really good at this in your head, you might think it's way more easy to think of it straight up mathematically than the stair chart. But a lot of you might think the stair chart's easier. Both I want you to at least somewhat understand and do whatever's comfortable. What I care the most in the end is that we eventually get it right. Okay? So that's essentially what we did mathematically. Divided that number by 100 to give us 0.0025 meters. So at this point I would hit check answer, and if we got it right, it'll always say that away and show our progress. So we'll continue on. All right. Let's do another one here real quick. We got about 5 minutes left in class. We'll keep going to the end here. We have 37 milliliters, and we want to convert that to liters. Now notice what they did here. The original number given right here in the problem does not have a decimal showing, right? But as you probably already know, but I'm going to say it anyway, if there's not a decimal showing, the decimal is always at the very right end of the value, right? So that's where we put it. So we're going from milliliter to liters. So again, if necessary, let's look at that flow chart. The prefix is milli and liters is a base unit, right? So how many steps away is milli from the base unit? 3. So we know we're going to move the decimal 3 times. And what way do I go when I move up the steps? To the left. So again, we're moving to the left, but this time 3 times. And by the way, if you're unsure, liter is the base unit for volume. A lot of times you'll hear that with drinks, like a 1 liter bottle or something like that. So we should be kind of familiar with it from that. So 3 places to the left. Remember, when we move to the left, that's dividing. And this time, since I moved 3 places, remember, power's at 10. 10 times 10 times 10 is what? 1,000. So I did by doing that chart that way, I did the equivalent of mathematically dividing it by 1,000. I checked my answer, and I go on. One other quick thing I want to point out today. We're not going to finish all 6 of these. As a matter of fact, later in the week or early next week, you're going to do the whole thing on your own, so I don't want to do all of them. But one thing I don't want you guys to do ever with concept builders is think it's a good idea to just guess, all right? Because you'll be kind of penalized. When you get ones wrong and you hit continue, it'll say, oh, drats, okay? And then you'll keep moving on. But if you keep getting ones wrong, you'll never finish the assignment. Because they kind of penalize you for every one they get wrong, they make you do a makeup question. And the reason why they do that is so people just don't randomly guess till they get everything right. So don't do that. If you are struggling with these, if you're in class with me and you're struggling with them, I'm right here for you to ask me. If you're at home struggling with these, don't just get a million wrong. Contact me and say, hey, I'm having trouble with this. I'll get back to you as soon as possible to try to help you out. So I'm going to keep going over the announcements here because we don't have much time. When I do officially assign one of these for you for the first one, I'll talk a little bit more about what to do at the end and how to turn it in. Because again, we may or may not soon have the paid version, so that'll determine that. So hopefully this gave you a little bit of refresher on the metric system, and also gave you some introduction to like how some of this stuff we're going to be using in class works, like the website in general and the concept builder. So no assignments today on this. We'll continue on in the future with it.